Hi everyone, and welcome to the WCRL Electronics and Coding with Arduino guide. I'm Sam, and in this video we'll go through the different kinds of electronic setups you can use, how to build your WCRL PCB, and take a look at the Arduino code. In addition to this video, we also have the Getting Started video, design guide, and 3D printing and assembly guide. We plan on adding more videos, such as a guide for using the Raspberry Pi Pico, in the future. We recommend watching the whole series before starting your bot. There are a number of different ways you can control your bot, starting with the Arduino and WCRL PCB combination that we'll cover in this video. This is the most supported setup for WCRL, and so is recommended for beginners. With this setup, you'll control your bot via Bluetooth from the Dabble or BitBlue phone app. Another microcontroller you can use besides the Arduino is the Raspberry Pi Pico. If your team wants a challenge, you can also design a custom transmitter and receiver using Arduino radio modules or RF nanos. Lastly, you can ditch an Arduino or Raspberry Pi by using an RC transmitter and receiver, but this is something that you'll have to pay for and you don't get experience working with microcontrollers. Buying an RC controller counts towards the $125 budget limit, but building your own does not. This slide shows what electronics are provided by WCRL and which ones you'll have to source yourself. WCRL provides the WCRL PCB board, connectors, wire, crimps, Arduino nanos, DC motor drivers, LEDs, buck converters, and batteries to borrow. We don't provide drive motors, brushless motors, or ESCs, servos, or wireless connection modules. We encourage competitors to do some research to find the best electronics for your bot, and you can ask a build technician or other competitor for their recommendations. You won't need to buy any tools to build your bot, as the Fab Lab has everything you need for assembly. The WCRL board may be overwhelming at first glance, but there's plenty of information to help you master it. First, we'll walk through how to view the board info online, then we'll go step by step on how to set it up in person. You can access the WCRL board info by going to the electronics folder in the Build the Bot GitHub repository, which is linked in the description. To view the schematic or 3D model of the PCB, first download the zip folder for the latest version of the PCB, then go to Altium Viewer, which is also linked in the description, and upload the zip folder to the site. You can use the menu on the top to change viewing modes, which is really helpful for figuring out where a trace connects or where to put a connector. Now, let's walk through how to set up the PCB. We want to go from this to this, which will probably take a few hours of work. The components you need can be found in the WCRL bins in the Fab Lab. You will need an XT60 right angle connector, 1 or 2 XT30 right angle connectors depending on the amount of weapons you have, 1 male 4-pin JST connector for the Bluetooth module, 2 or 4 male 3-pin JST connectors depending on the amount of motors you have for drive, 1 male 2-pin JST connector for the LED, 1 or 2 male 2-pin JSTs depending on the amount of weapons you have, and a 200 ohm, 1 kilo ohm, and 2 kilo ohm resistor. I recommend just grabbing a bunch of everything from the bins and then putting the rest back after. You'll also need an Arduino Nano and a SparkFun DC motor driver if you're using the DC brushed motors. First, let's set up the Arduino and DC motor driver on the board. In the WCRL bins, you'll find long rows of these female connectors. To cut them to size, you'll need to cut 15 pins for the Arduino and 8 pins for the SparkFun motor driver. You can cut them with flush cutters or wire cutters. Once you've cut them to size, you'll put them through the holes in the PCB and solder the bottoms on the bottom of the board, like that. The Arduino and the DC motor driver will also need pins installed. So this one came with pins pre-installed, but ones from the WCRL bins might need the pins installed by you. To do that, take these male pins that you could find in the bins and cut them to size. Same thing, 15 pins for the Arduino and 8 pins for the motor driver. Then stick the small end of the pin up through the board and solder them on the top like this. After this is done, you'll be able to put your Arduino and your motor driver in the board like this. Also know that the top of the SparkFun motor driver is the part that says SparkFun on it, as you can see in this picture, which is the correct way to orient the Arduino and the motor driver. Next, let's attach the XT60 and XT30 right angle connectors. These XT30s are for power to your weapon ESC. So your weapon ESC will probably have a thicker red and a black wire coming out of it. That's for power. And so you'll want to solder a male XT30 connector to those wires. Make sure you know that which side's positive and which side's negative. Usually the more square part is the positive end on these connectors, whereas the rounded part is for the negative end. On the board, get these right angle connectors and put them through, and then solder them on the bottom like this. If you only have one weapon ESC, you'll just need to put in this connector, but if you have two, then you can put in both of these. The XT60 is what your battery will plug into, but you can't just plug it in directly here. You'll need a kill switch that is easily accessible per the WCRL rules. What I like to do is create a wire harness where I get a male XT60 like this to plug into the battery. I then solder a wire from the negative end of this connector to the negative terminal on this PCB. I then solder a wire from the positive end of this connector and then attach that wire to one end of a switch or another XT60 like this, and then the other end of the switch or this XT60 I solder to the positive end of this board. This way, when I flip the switch or I put in a jumper cable into this connector, it completes the circuit between the battery and the PCB, which will allow everything to be turned on, and this is a kill switch that you can easily access from outside the bottom. These male JST connectors can be soldered the same way as the other connectors by putting them through the holes on the PCB and soldering on the bottom. While you can solder the components directly to the PCB, using the JST connectors allows you to easily switch out components without having to resolder them. To connect these female JSTs to a component like this, you'll need to crimp the wires from the component and then push them into the connector. FabLab Tech or Build Tech can help you if you've never crimped a wire before. But then, after this is crimped, you can just plug these in to the connectors on the board. The WCRL board also has text on it that tells you which way to connect the components. For the LED, you can see that the black end, or the negative end, will go where it says ground here, and the positive end, which is usually the longer leg of the LED, will go on the left side here of this connector. For drive motors, just connect the outer two pins here and leave the inner one empty, or the middle one empty. And for drive motors, the orientation of which way you connect the wires doesn't matter, because if the motor is going the wrong direction, you could change it later in the code pretty easily. For the Bluetooth module, you'll see that this right pin is labeled 5 volts, which means you should attach it so that the 5 volt pin is here. And then for the weapon ESC, sometimes the ESC will have 3 small wires coming out of it, and you can ignore the red wire because that's to power a separate receiver through a BEC, which you won't need with this board. And then solder the black wire so that it plugs into the ground port, which is on the right here, and the white wire, which is the signal wire, should plug in to the left side of this JST connector. Lastly, install a 200 ohm resistor here, a 1 kilo ohm resistor on the right side here, and a 2 kilo ohm resistor on the left side here. Setting up this PCB can be difficult, but a Build Tech can help you out if you're having trouble. Let's pivot from the electronics to the code. To download the code for your bot, you'll first need the Arduino IDE if you don't already have it on your computer. Once that's installed, go over to the Build the Bot GitHub repository and navigate through the folders until you find the appropriate code for your bot. If you're planning on controlling your bot with an iPhone running iOS 16 or later, you will want to use the BitBlue code. Otherwise, you can use either code, but most competitors stick to Dabble. Once you've gone through the folders, you'll want to download the .ini file, which is the code itself, and the SparkFun library folder, which you can install by going through the online tutorial. All these links will be put in the description. Let's walk through the code for a bot with one competition attachment that's using Dabble. This first line includes the Dabble library, and you will have to follow these instructions when you first set it up. You can access your library files by going to the Arduino folder in the Program Files x86 directory in your C drive. Next, this code includes the Servo and SparkFun libraries and creates a servo object for the ESC. These lines of code define the pins where your drive motors are connected to. If you built your WCRL PCB without any modifications, these pins shouldn't need to be changed. But if you did make some modifications to which pins you plug your motor into, then you could change those pins here. These lines create motor objects for the left and right wheel. And in the setup function, we initialize serial monitor, dabble, and the ESC. Now, let's go into the control loop. If you find that one of your motors is going backward when you try to go forward, you can just change the sign in whichever wheel is going the wrong way. So let's say my left wheel is going the wrong way. I would just negate the value in these parentheses and make the value positive in these parentheses. And you could also change the number itself to change the speed of the motor. This code controls the competition attachment. By default, it's set up so that when you press triangle, the competition attachment will start up. You press circle to increase the speed, and cross to shut it off. You can tweak these buttons and the numbers for the speeds to your liking. Lots of problems can come up when dealing with the electronics and coding. If you're stuck with something, stop by a Build Tech's office hours to get some help. If you have any questions, you can also contact WCRL at binghamton.edu. Thanks for watching.